You know that feeling when a software project just seems like, well, like barely controlled chaos? Like it's a disaster just waiting for the right moment to strike? Today, we're going to talk about how the best teams transform that chaos into a calm, controlled, and, a predictable process. This is the journey from chaos to control, and it's all powered by something called software configuration management.
Oh man, does this sound familiar? Picture this. It's 2 a.m. The big launch is just hours away. You merge what you think is the last set of changes, and boom, the whole system just dies. Nobody knows whose code did what. And the worst part, nobody can even agree on which version was the last good one. This isn't just a story. For a lot of teams, this is a painful reality.
Okay, let's be real for a second. Come on, raise your hand if this has been you. You're working, you hit save on a file, and just like that, poof, hours of your teammates' work is just gone. It's that awful sinking feeling in your stomach, and you know what? It happens way more than any of us want to admit.
Or what about this one? This is a classic. You and a teammate have both been editing the exact same file, and now your version control tool throws up its hands and gives you this screen full of just gibberish and conflicts. And now it's up to you to manually, painstakingly try to stitch two different realities back together without breaking everything. It's a nightmare.
And of course, my personal favorite, the old final v3 real.py. I think we've all been there. This is basically the universal sign of desperation, right? When your project folder looks more like a cry for help than a professional directory, you know you're living in chaos. And this is exactly the problem we're here to solve today. So, how do we escape this development mess? Well, the answer is a discipline, a process, and a whole set of tools that we call Software Configuration Management, or SCM for short. This is the hero of our story.
Okay, so let's put a formal definition on it. SCM is a systematic way to manage the entire life of a software project. And here's the key thing to notice. It's not just about the code. It's about everything. We're talking the requirements docs, the design files, the test cases, and yeah, of course, the source code. SCM is the framework that brings order to all of those moving pieces.
So what's the point of all this? Why bother? Well, the goals are super practical. It's all about making life easier. SCM helps boost your team's productivity because people aren't constantly stepping on each other's toes. It helps you handle it when multiple developers need to work on the same stuff. It makes sure you can actually build your software reliably, and it even helps you track bugs all the way from when they're found to when they're fixed.
Now, to really get how SCM pulls all this off, we need to look at its 4 foundational pillars. Think of these as the core principles that make the whole system tick. All right, let's break this down. First up, you've got identification. This is basically where you decide what's important enough to track. Think of it like a librarian making a catalog card for every book. Your books here are things like a specific module of code or a design document. Next is control. This is your gatekeeper. No more random changes. Before anyone can modify a critical file, they have to submit a proposal, it gets reviewed, and then it gets approved. Simple as that. Third, auditing. This is the reality check. You're constantly comparing what you have to what you think you have. It's like checking the library shelves against the catalog to make sure no books have wandered off. And last but definitely not least, status accounting. This is the project's history book. It logs every single change, who did it, when they did it, and why. You get a complete traceable story of how your system came to be. Okay, so that's all the theory. But what does this actually look like in the real world? Let's pop open the toolkit and see how teams put these ideas into practice every single day. So one of the most fundamental things is versioning. Instead of that final _v3_real nonsense, we use a structured system, often called semantic versioning. A number like 7.5.4 actually tells you a story. That first number, the 7, that's the major version. It only changes when you make big, breaking changes. The second number, the 5, is the minor version. That's for when you add cool new features, but in a way that doesn't break anything. And that last number, the 4, that's the patch version, for simple, backward-compatible bug fixes. It's a language all on its own. And here's a really important point. SCM is not a one-size-fits-all kind of deal. You have to pick the right strategy for your team. On the left, you've got something called Gitflow. It's got a lot of structure with different branches for features, development, and releases. It's amazing for really big teams that have strict release cycles. But on the right, you have trunk-based development. It's much simpler. Pretty much everyone works off one main branch.
It's perfect for small, fast-moving teams that are pushing out updates all the time. The right choice totally depends on how your team works.
Now, let's talk about SCM at a scale that is just almost impossible to imagine. 2 billion. That's the estimated number of lines of code in Google's single massive source code repository that runs pretty much everything they do.
And get this, every single day, their developers make over 40,000 commits. That's 40,000 individual changes to that one repository. Trying to manage that kind of speed and complexity would be absolutely completely impossible without an incredible SCM system. So, how in the world do they do it? Well, it all comes down to heavy automation and those core SCM principles we talked about. Every single one of those 40,000 commits automatically kicks off a giant suite of tests. If anything breaks, they have the control to roll it back in an instant. And because of status accounting, they have a perfect auditable history of every change ever made. It's SCM delivering control on a totally breathtaking scale. You see, SCM isn't just about managing code. It's really a guardian of your product's quality. It gives you the structure you need to handle one of the trickiest parts of software development, finding and fixing bugs.
Just look at this process. It is the polar opposite of that 2 a.m. panic from the beginning, right? There's no guessing, no finger pointing. A bug gets found and it gets formally logged in a system. It's validated to make sure it's a real bug, then it's analyzed, given a severity, and assigned to a developer. They fix it, a tester verifies the fix, and only then is it closed and scheduled for release. Every single step is deliberate, it's tracked, it's managed. It brings order to the chaos of bugs.
Now, a really important idea in modern SCM is something called a software bill of materials, or an SBOM. And this analogy is just perfect. You know how a car maker has a list of every single nut, bolt, and wire that goes into a car? An SBOM is exactly that, but for your software. It's a detailed inventory of every library, every framework, every little component that makes up your application. So why is this so important? Well, it really comes down to 3 huge things. First, security. When a massive vulnerability like Log4Shell happens, you don't have to scramble. Your SBO can tell you in seconds if you're affected. Second, compliance. It helps you keep track of all the open source licenses in your project so you don't accidentally get into legal trouble. And third, traceability. It just gives you a super simple automated way to answer basic questions like, hey, which version of this library are we actually using? So let's bring it all together. We started this whole thing with that 2 a.m. deployment disaster. And since then, we've looked at the principles, the tools, and the processes that offer a much, much better way. We've seen how SCM is really the key to transforming development from that state of chaos into a state of control. And the payoff is crystal clear. When you have good SCM in place, you get orderly, structured development. You make sure that only approved changes actually make it into the product. You prevent accidents and unauthorized edits. You can even help guarantee that your documentation actually matches what the code does. And maybe most importantly, you have a way to really understand the impact of a change before you make it. In short, you get to replace chaos with control. So I'll leave you with this one question. I want you to take an honest look at your own team, at your own projects. Are you still naming files final_v3 and just crossing your fingers at 2 a.m.? Or are you ready to put a real system in place to truly control complexity and build better software faster and more reliably? The tools are out there, the strategies are out there, the choice is yours. Thanks for watching.